take a closer look at the relationships between length, area, and volume. We'll begin by looking at this rectangular prism here, and we'll notice that it has several dimensions. It's 4 units in length from here to here. It's 3 units of length from here to here, and it is 3 units in length from here to here. So the dimensions for this would be 4 in one direction, by 3 in another direction, by 3, kind of hard to show there, by 3 in a third dimension. And you will notice that there's kind of a connection here between the number of measurements possible and what we would consider the dimensionality of the cube. In other words, this is a 3-dimensional figure, which means that there are 3 units of length that we can attach to that, and we just showed what those were. So when you think about 3-dimensional figures, what that really is telling us is how many separate measurements we can make in terms of individual length. Now, when we think about the volume of this, volume would be the total number of smaller cubes that it is contained. So this rectangular solid has a certain number of cubes inside, and we can count them, or we can use our knowledge of multiplication and use that as a way of counting for us. So I'm going to put the cube like this, and we'll notice that this area from here to here is 1, 2, 3, 4, 5, 6, 9 units, or 3 in one direction times 3 in another direction. And if we count the number of times that shows up, it shows up once, twice, 3 times, 4 times. So we would expect then that whatever answer we get when we compute the area, that tells us number of cubes in one slice, we would multiply that by the number of slices, and that's how we would generate our volume. So our volume would be 3 times 3 times 4, which is what would be expected. And in your fill the room assignment, this is the understanding for volume I'm sure that most of you are using based on my reading of your work. Now, if we were to build a record of action for what we've done, it sometimes is helpful for young people to keep track of what it is we're working on and to build a really tight connect between the physical object and a sketch. And so you'll notice what I'm doing here is I've traced over the top so that at least this part of it's pretty accurate, and then I'll notice that I have 3 units. And so if I label this particular sketch now, we would notice that from here to here we would have 3 units. From here to here we would have 4 units, and from here to here we would have 3 units. So maybe I'll move this over here to make it a little clearer in terms of each of these 3 dimensions. Now, again, because it's a 3-dimensional figure, we need to label each of the 3 dimensions of a sketch. We also have to be kind of careful because it's very difficult to draw 3 dimensions in a 2-dimensional space, but it can be done with a little bit of care and a little practice. And so the first step in teaching volume is to make sure that you can represent it both with physical objects and with sketching. And depending on the developmental level of your students, you will probably want to start with physical objects as a general rule first. Let's now see what happens when we take this volume and ask ourselves a rather interesting question. What is the area contained in the square of smallest perimeter. Now, perimeter is distance around, and so what we want is we want to say, what is the smallest rectangle that we can build that uses all of these cubes? And I'm going to just kind of jumpstart the discussion here. In terms of perimeter, when we talk perimeter, we're talking about total distance around. So the distance from here to here is 6. And because this is a square, we were rather careful about that. The distance from here to here is 6. Distance from here to here is 6. Distance from here to here is 6. And so what our perimeter would be in this case would either be 4 times 6, or we could add up each of these 4 sides. Shades of pond, ma, kettle, isn't it? Now, perimeter is not the same thing as area, because if we were to ask what is the area of this figure that we created, the area of this figure would be 6 times 6, wouldn't it? And we could always count it. We could go 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 18, 24, 30, 36. Or we could just make use of a little bit of old-fashioned do it, dang it, talk. And we notice we've pretty well done it, haven't we? What are we going to do? Well, we're going to build a rectangle, 6 by 6. We count up, and we get 36 for the area. So you see, perimeter and area are related, and sometimes it's confusing to children because they see the same numbers show up in some cases. You have to remind them that for perimeter, you're talking about the distance around. And so if I imagine I'm a little marching ant and I'm marching across here, I would march 6, 12, 18, 24. When we're talking area, we're talking about the distance inside. And so I would add up each of those squares and count them, and that was how I'll get the distance between my area and my perimeter. You'll notice that in terms of dimensions, when we were talking about volume, we had volume as being 3 dimensions, so there was 3 measurements involved, and for this figure it was 4, 3, and 3, and when we add all of those, multiply all of those up, 3 times 4 is 12, times 3 was 36. So our volume for this number of cubes was 36, and the units, I'm going to say, call this a C to stand for cube. The units would be C to the 3rd power. And when you take your measurements, you will notice that the 3rd power is kind of a clue that it's a 3-dimensional figure. That'll help you tie that together for your students. When we look at the area, as we are here, we see that the area is 6 times 6. Oh my goodness, that's rather a surprise, isn't it? It's also 36, but there's a difference here. We're no longer talking about cubes, we're talking about c squared. We're talking about the area. And again, that's a reminder that we're using this in terms of centimeters squared rather than centimeters cubed, or cubes squared rather than cubes cubed, if it were. When we now take a look at length, we're going to have the same number of cubes, so we know we're going to be having 36, only for length we only have a single dimension. And so we'll just say 36 cubes. So we ask ourselves, well, what would that look like? Well, for length, we're going to have to snap these together so that they are end to end. is a linear arrangement of cubes that are 36 units long. All right, welcome back. Now, one of the things that often surprises students is just how long the length turns into. The thing about volume is because it has 3 different dimensions for the cubes to spread out in, it tends to be compact. And in fact, if you remember, when we created our rectangular solid originally, it was relatively small. In fact, we could draw a sketch of it that fit on quite nicely. Area got to be a little bit bigger, took up more of the space, and length, because it only has a single dimension to spread out in, takes even longer. And just to show that, I'm going to kind of drag my ruler across here, and you might be a little bit surprised in terms of just how far this goes before we reach the end of the 36 cubes. You know, it's almost surprising, isn't it, to see just how far that goes when we no longer are considering it in terms of either area or in terms of volume. And so when you did the counting the room assignment, a lot of you were surprised about how many cubes it took to fill up that volume. In the assignment for this week, you're going to be taking that a little further and saying, well, what would be the area for those cubes? What would be the length for those cubes? I believe you'll be even more surprised when you realize just how long those cubes would be when you stretch them out end to end. I'm hoping that you see some of the relationships between the formulas for volume, area, and length. And yes, there is a formula for length if you measure it. And the dimensionality involved. We measure cubic centimeters. We show that with the c to the third. We use square centimeters, that's c to the second, or just the length in centimeters if we're using standard centimeter cubes.